Let's learn about the conjugate zeros theorem. For example, let's find all the zeros of f, given that 1 minus I is a zero. Now, since this polynomial here has real coefficients, the conjugate zeros theorem tells us that if this polynomial has complex zeros, then they have to occur in conjugate pairs. And because we're given that 1 minus I is a zero, then 1 plus I, its conjugate, is also a zero. And therefore, x minus each of these zeros are factors of f. And therefore, so is their product. That is, x minus 1 minus I times x minus 1 plus I is also a factor of f. But what is this product? We'll FOIL. This is equal to x squared minus x times 1 plus I minus 1 minus I times x, and then plus 1 minus I times 1 plus I, which is equal to x squared. Now distributing the x, we get negative x minus xi. Again, distributing both the negative and the x gives us negative x plus xi. And then we'll FOIL again here. We get 1 plus I minus I, and then minus I squared. So negative xi and positive xi cancel, as well as I and negative I. And remember that I squared is equal to negative 1. So therefore, this is equal to x squared minus x, which is minus 2x, and then plus 1 minus a minus 1 is plus 2. So this is their product. And because this product is a factor of f, that means that f of x is equal to this x squared minus 2x plus 2 times some polynomial q of x. And we can find q of x by dividing f by this. So let's do that. All right, x squared goes into x cubed x times, and x times x squared minus 2x plus 2 is x cubed minus 2x squared plus 2x. And now subtracting, we have negative 5x squared minus a minus 2x squared is negative 3x squared. And then 8x minus 2x is plus 6x. And we still have the negative 6 here. Now x squared goes into negative 3x squared negative 3 times. And negative 3 times x squared minus 2x plus 2 is negative 3x squared plus 6x minus 6. And when we subtract, we get 0. Which shouldn't surprise you because this is a factor of f. So the division should yield a remainder of 0. So therefore, this is q of x. And if this is q of x, that means that x minus 3 is a factor of f. And therefore, 3 is our other 0. So that is our zeros are 3, and then the two complex conjugates, 1 minus I and 1 plus I. And this is how we work with the conjugate zeros theorem. Thank you, and we'll see you next time.